Hello, it's Miss Coletta here to discuss with you a few ways to find slope. What do you think of when you hear the word slope? For me, I usually think about how steep something is, such as how steep a hill is. Now in math, when we talk about slope, we're also talking about how steep something is. But we'll usually talk about the slope of a line. And when we talk about the slope of a line, there are a few ways we could see our examples. One could be to find the slope between 2 points that form a line. One could be to find the slope from the graph of a line. Or, the last way that we might talk about slope is to find the slope from the y equals equation for the line. So today we'll start with looking at the example of finding slope between 2 points. Now you'll notice up in the top I have the slope formula. M equals. For some reason we use M in math to stand for slope. And then we have this little triangle symbol. This triangle is the Greek letter for delta. So this is read delta y over delta x. And delta stands for change. So this is the change in y, or how much it goes up, for every change in x, how much we move over. So if you're thinking about a hill, how much you climb up as you're trying to move across the hill. And then, when we're finding the slope between 2 points, we have this other part of the formula, y2 minus y1, which just finds us the change in the y, over x2 minus x1, which finds us the change in the x's. And these little subscripts 1 and 2 that you see, that just shows you that this x and y belong with one point, and this x and y belong with a different point. So let's take a look at an example. In example 1, I have 2 ordered pairs, 3, 6, and 5, 3. Now every time when I start with the slope between 2 points, I first label my points x, y, so that I remember that the first number in an ordered pair is always x, and the second's always y. Then I write my formula down. And now I'm ready to plug in my numbers. Now when you plug in your numbers, you can start with either point that you want to. But it's important that once you pick a point to start with, you use that every time you have to start a part of the problem. So for instance, if I choose this y equals 6 to be the first y I write down, then I'll write 6 minus, and then I just write the other y, this 3 up here. So 6 minus 3 goes up top. Now, you'll notice in the formula that this y2 has the subscript 2, and the x down here has the subscript 2 as well. That means that these two letters, x and y, come from the same point because the 2's match. So if I started using this y from this point, I have to start by using the x from the same point. So I'm using this x3. So I write down my 3, and then I'm going to subtract my other x, which is 5. Now, when I do this, I just go ahead and simplify both the top and the bottom of my fraction. 6 minus 3 simplifies to give me 3. 3 minus 5 simplifies to give me negative 2. And I can do that either in my head or by subtracting in my calculator. Now what I like to do is make sure that my fraction is as simplified as possible, which means that I can't reduce it at all. Do you know if 3 over negative 2 can reduce? Well, it turns out that it can't. It's as simple as it can be. But if you want to check in your calculator, all you do is type 3 divided by negative 2, and then if you're using a TI-83 or above, you hit the math button, and then you hit enter twice, and it will reduce any fraction that you have. And if you do that, the only change that your calculator will make this time around is it will put the negative 3 over a positive 2. And that's how I'm always going to want to write my answer, with the negative on the top part of the fraction. It seems random right now, but it will be very helpful to us as we move on in other examples. So here, you'll notice we had 3 divided by negative 2, but I'm writing my final answer as negative 3 divided by a positive 2. And in fact, those two answers are equal. There's one other way we could write that fraction and it would still be equal, and that's if we put the negative out front and then a 3 over 2 by itself. But again, the way that I like to write it for our further use later is with the negative on the top part of the fraction. But I just wanted to show you that all three forms are in fact equal. I'm just going to go ahead and get rid of this because our final answer is good as -3/2. And we'll move on to our next example. So again, I start by labeling my points, xy and xy. Then I write my slope formula. And then I'm ready to plug in my numbers. So I'm going to start first with this -2 as my y. And then I need to subtract the other y. And the other y value is a -7. Now be careful here because we have, if you notice, we are subtracting a -7. And some students get confused when there are two signs there. This is a subtraction, this is a negative. If you get confused, you can put parentheses around that -7 so that you don't forget that there are two different signs there. You don't have to, but it's an option that you can do there, and I'll leave them there for this problem. Then I'm going to subtract my x's. So because, again, I started with this -2, I need to start with the x from the same point. So I'll start with the -4. And then I'll subtract the other x, 6. And then we're just going to simplify it. So to simplify the top, I would type into my calculator -2 minus -7. And when I do that, I should get a +5. And I would subtract in my calculator -4 minus 6. And when I do that, I should get a -10. Does anyone know what that reduces to? Well, in fact, it reduces to -1/2. But if you weren't sure, you could use that math fraction option in your calculator again. Notice again that I moved that negative to the top of the fraction, which will be key for us later when we're doing a little bit more with slope. Okay, are you ready to look at a different way to find slope? Let's move along. Now we're going to look at how to find slope from a graph. Now, when we find slope from a graph, the first thing we really want to do is locate 2 points, because what we needed before was 2 points to find slope. And when we're looking for points here, we want to pick points that are on nice, even grid lines. And what I mean by that is that it hits both the x and y at whole numbers, if possible. So when I'm looking at example 1, as I trace along this line, I'm looking for somewhere where it hits at a nice, even grid line. And one point that I see is right down here. So I'm going to put a little dot right there. And then the next point that I see is right here. Now you don't necessarily have to pick exactly the same points as me to get the right slope. As long as you pick one that falls on a nice even grid line, you should get the same slope as me. For instance, some of you might have picked the point right here that's down 2 on the y-axis. That would also be a good point to use. Now once you do this, there's 2 ways you could approach the problem. The first way is to write out the ordered pairs for these points and then approach it in the same way that we just did our other examples. So if I wrote out the ordered pair for this first point right here, I went over 1 and up 1. So the coordinates would be 1, 1. Looking at this second point up here, I went over 2 and up 4. So the ordered pair here would be 2, 4. Once you've written that, you could do that slope formula that we just did with 2 points on the last page. But I'm going to show you a little bit of a shortcut now that we have the graph in front of us, that we can do the slope using just the picture. Now notice in my formula box that my formula has changed a little bit. Instead of y2 minus y1 over x2 minus x1, I have rise over run. Now when you hear the rise word, you should think either up or down, right? Rising, getting up in the morning. When you hear run, you should think about moving across. So that still represents your change in y, and run still represents your change in x. We've just changed our terms a little bit. Now, when we look at our graph, we always want to move from the left to the right. So I'm going to start at my leftmost point, and now I'm going to show you the shortcut of how to use the graph to find slope. Now, if I need to rise, do I need to rise up or move down to get from this point to this point? That's right, I need to move up. So I'm going to draw an arrow here of how far I need to move up. And if you look here, if I count the blocks, I moved up 3. Then, when I go to run, I need to move over to the right, and how many blocks did I move over? Just 1. Now, when we go to do slope, we write m equals rise over run, and then we just write the rise that we got, which was 3, and the run that we got, that was 1. Now, you should know that 3 divided by 1 gives you 3, but if you weren't sure, you could reduce that in your calculator and you would get 3. It is possible to get a whole number answer for your slope. We like to either report fractions or whole numbers. In this case, we got a nice whole number answer. So our slope is 3. Now we'll move on to the next example. Again, I'm looking for nice, even points on nice grid lines. So the first one that pops up to me is that one right there, and the next one would be right there. Now remember, we travel from the leftmost point. So here's my leftmost point. Now, do I generally need to move up to get to the other point or down? That's right, I need to move down. And I need to move down 2 blocks here in order to get even with that other point. Now, in order to show that we're moving down instead of up, I'm going to make this a -2 instead of a +2. And then I need to run over the other way, and how much did I run over? 3. Now I write my rise over run for my slope formula. And then I just put in the numbers I found. My rise in this case was -2, and my run was a +3. I check in my calculator to see if that can reduce, and it doesn't. So that's my final answer. So that's how to find slope from a graph. Now, last but not least, we have how to find slope from a y = equation. And this, I think, is actually going to be the easiest one for you. Again, we have the same slope formula, just to remind you that slope is still the change in y over the change in x. But this time, it's going to be the coefficient on the x term when we're looking at the y = equation. And coefficient is just a fancy word for the number out front. So, these examples are going to fly. Check it out. Example 1. When I'm looking for the coefficient on my x term, that just means the number in front of my x. So when we look at y = 5x + 7, what number is in front of x? A 5. Now notice I do not write the x with the slope. Up until now, we've always just had a number as our answer, and this isn't any different. In the y = equation, we have x and y, but we'd never write x as part of the slope. That's a common mistake that some students make. Let's check out example 2. M equals, I'm looking for the number in front of x, and I get -5/8. Done. Now look at example 3. You might notice that the order changes. Instead of having x first in the equation, I have it second. But no big deal. I'm still looking for the number in front of x, and that's a 2/3, 2/3. And last, but certainly not least, example 4. So let's take a look here. Now be careful here. Our equation is y = 6 minus 2x. So a lot of students would say the slope is 2. But what are we doing with that 2? We always look to the left to see what sign goes with the number, and in fact, it's a -2 because we're subtracting there. So the slope would be -2. So make sure you always look to the left of your number to see what sign it is. Well, that's about it for finding slope. I hope you found these examples helpful.